Today we are looking at measures of location and spread in mechanics and statistics. Measures of location tell us where the middle of the data is, and measures of spread tell us how far the data is scattered from that middle. In plain words, the mean equals the sum of all the values divided by the number of values. In symbols, that is, mean equals the sum of x divided by n. In plain words, the variance equals the sum of the squares of the values divided by the number of values minus the mean squared. In symbols, that is, variance equals the sum of x squared divided by n minus the mean squared. In plain words, the standard deviation is the square root of the variance. In symbols, that is, standard deviation equals the square root of the variance. Now let us work through an example together. Find the mean and the standard deviation of the 5 values 4, 7, 9, 10 and 5. Step 1. Find the mean. First add up all the values, 4 plus 7 plus 9 plus 10 plus 5, which gives 35. Then divide this sum by the number of values, which is 5, giving a mean of 7. Step 2. Find the sum of the squares of the values. Square each value. 4 squared is 16, 7 squared is 49, 9 squared is 81, 10 squared is 100, and 5 squared is 25. Add these squares together, 16 plus 49 plus 81 plus 100 plus 25, giving 271. Step 3. Find the variance using the computational form. Divide the sum of the squares by the number of values 271 divided by 5, giving 54.2. Then subtract the mean squared. 7 squared is 49, so 54.2 minus 49 gives a variance of 5.2. Step 4. Take the square root of the variance to find the standard deviation. The square root of 5.2 gives a standard deviation of approximately 2.28. Check step. Let us confirm this using the deviations from the mean instead. The deviations from the mean of 7 are -3, 0, 2, 3 and -2. Squaring each deviation gives 9, 0, 4, 9 and 4, which add together to give 26. Dividing 26 by 5 also gives 5.2, which matches our earlier variance exactly. So the variance is 5.2 and the standard deviation is 2.28, and these are two separate values, never to be confused with each other.